Hello guys, welcome back to a new session. In today's session, we will be talking about the first section of chapter 7. You know that the chapter 7 is all about three sections. The first section, we will introduce the oxidation and reduction reactions. And then in the second section, we will be talking about the balancing redox reaction. And the last section, we will be talking about the oxidizing and reducing agents, guys. The section, as I told you, we have three sections. The chapter distributed into three sections. Let us talk about the first section, introduce the oxidation and reduction processes. Guys, the term of the oxidation and reduction processes refers to the changing the oxidation states of the elements from the reactant to product. Whenever the oxidation state of an element or atom changes from the reactant to product, whether it's increasing or decreasing, there will be a change, and then those changes represented by the oxidation and reduction. Guys, oxidation reduction involves a transfer of electrons. So here we have the transferring of electrons. Transferring of electrons, the reactions, a group of atoms, usually the metals, they have a high tendency to lose electrons. So we'll call them as oxidized. We'll be talking in detail. And the other group of atoms, usually the nonmetals, they have a great tendency to attract electrons and gain electrons, and we will call them as reduced, or reduction occurs of them. So let us define the oxidation and reduction. What do we mean by the oxidation, guys? Oxidation involves the loss of electron. Oxidation involves the loss of electron. Oxidation is losing electron. With the oxidation, there should be a reduction always, which is the gain of electron. Reduction is gain. Oxidation is loss. Reduction is gain. Gain of what and loss of what? Of electrons, guys. Reduction and oxidation have reactions must occur simultaneously, guys. We have to process in a reaction. Whenever there will be one of these process, the other must be existed with it in order to meet the law of conservation of mass, to not let the electrons to be losed or gained without any other process. Oxidation number, or we will be talking about the oxidation number, guys, and the rules how we can calculate the oxidation number, because in order to determine whether an atom oxidized or reduced, we have to know what happens to its oxidation state. Assign the oxidation number assigned to an element in a molecule is based on the distribution of electrons in the molecule. So the oxidation number talks about the distribution of the electrons in a molecule. Let us talk about how to find the oxidation number. What are the rules, the main rules for finding the oxidation number? Probably you have studied this previously, guys, but let us talk about them again in order to know how to assign the oxidation numbers, because this is the basic for the balancing redox reaction. Without knowing what will happen to the oxidation numbers, we will not be able to balance in the second section, guys. The first rule which we have is the atoms in a pure uncombined element have an oxidation number of 0, guys. Any element in a pure form without reacting to the other atoms or elements, it has an oxidation number of 0. Examples: sodium, zinc, H2O2, aluminum, carbon, so many, all of the elements in the periodic table, when they are existing in pure form, their oxidation number equals 0. How about those elements which they form ion but they are monatomics? They form a monatomic ions. The oxidation number of monatomic ion equals to the charge of the ion. Equals to the charge of the ion. For example, here in this case, guys, Fe positive 2, it has a charge of positive 2, and the same time it has the oxidation number of positive 2. S negative 2, it has the charge of negative 2, so its oxidation number is negative 2. Ag positive 1, oxidation number of positive 1. Br negative 1, oxidation number of negative 1. This can be applied for all of the monatomic ions. Whenever the monatomic ions, we are required to find their oxidation number is equal to the charge of their ions, guys. The third rule, guys, it talks about the first and the second group elements. Guys, the first group element, they have an oxidation number of 1, and the second group elements, they have an oxidation number of 2, with the aluminium, which is oxidation number of positive 3. This is unchanged, and we have to know whenever an element, lithium, sodium, potassium, rubidium, and so on, they have an oxidation number of positive 1, whenever the group 2 elements, beryllium, magnesium, calcium, strontium, and so on, they have an oxidation number of positive 2. With the aluminium as well, aluminium's oxidation number always is positive 3. Why not the other D block elements? Because the other D block elements with different compounds in different forms of compounds, there will be change in their oxidation number usually. Guys, let us talk about the fourth rule. It's about the fluorine. Fluorine, guys, F negative 1, always without any exception, it has an oxidation number of negative 1 with any other atoms. Why? Because it's the most electronegative element in the periodic table. It has the highest tendency among all the atoms in the periodic table, all the elements in the periodic table. It has the most tendency to attract to electrons. For example, in NaF, oxidation number of fluorine is negative 1. In CaF2 is negative 1, in BrF is negative 1 as well. About the oxygen, the fifth rule talks about the oxygen, guys. Oxygen has got 3 states of oxidation number. 3 states of oxidation number. Usually it's negative 2. Usually. In usual cases, oxygen, usually in the compounds, it's negative 1. But when it combines with F, it will form two compounds, OF or OF2. Guys, in the OF, because F is negative 1, oxygen becomes positive 1. In the OF2, because oxygen is fluorine is negative 1, oxygen becomes positive 2. So in these 2 cases with fluorine, its oxidation number is not negative 2. It's an exceptional case. With the OF, it becomes positive 1. With the OF2, it becomes positive 2. How about the third oxidation number or position of the oxygen? It's with the peroxide, guys. With the peroxide, which is O2 negative 2, oxidation number of oxygen in the peroxide form is negative 1, guys. It's not, is what? Is negative 1. Have a look on the examples with the peroxide, guys. H2O2, K2O2, MgO2. How do we know it's peroxide? How do we know it's peroxide? Guys, the hydrogen is positive 1, oxygen is negative 2. If we form this, they will form H2O. But how about H2O2? It's hydrogen peroxide. It comes from H positive 1, O2 negative 2. And this negative crosses, we cross the charges, it becomes H2O2. This O2 is not from the charge of the hydrogen itself, it's in the form of peroxide, and the oxidation number of oxygen here is -1. K2O2, the same guys, K is positive 1, O2 negative 2, formed the K2O2. In this case, the oxidation number of oxygen is -1. MgO2 again, Mg positive 2, O2 negative 2. So these two charge, they cancel out, you'll get MgO2. Whenever the first group elements, the first group metals, combine with the oxygen, they will form 2O2. K2O2, Li2O2, Na2O2. These are peroxides. But whenever the group 2 elements, they combine with the oxygen, they will form 1,2, MgO2, CaO2, BaO2, and so on, guys. These are the forms of the peroxides. So, guys, the oxidation number of oxygen usually is -2, and with the peroxide is -1. With the fluorine, it has two forms, OF negative positive 1, OF2 positive 2. For example, in this case, guys, here CO2, we have got CO2. What will be the oxidation number of oxygen? Of course, it's not peroxide. It's not the case with the fluorine. Its oxidation number is -2 here in this case. How about the hydrogen, guys? Hydrogen's oxidation number, it has two forms or two oxidation states, guys. The +1, positive 1, or -1. The positive one is the usual case with the nonmetals. Whenever the hydrogen comes with the nonmetal, or combine it or reacted, bonded with the nonmetals, its oxidation number is +1. When the hydrogen reacts with the metals, the oxidation number becomes -1. Because of the metals, they have a high tendency to be positive oxidation number, and then they will let the hydrogen to be negative. Have a look on the following cases, guys. It's H2O. H2O hydrogen is with the nonmetal, so its oxidation number is +1. HCl, Cl is nonmetal, oxidation number is +1. But lithium hydride is what? The oxidation number is the -1, and MgH2 is -1 as well. So in these cases, guys, the oxidation numbers are -1 because the hydrogen reacts with the metals, but in the above two cases, the hydrogen's oxidation number is +1 because it combines with the nonmetal. The other rule about the oxidation number of the neutral compound is, guys, summation of the oxidation number of all atoms in a neutral compound equals 0. How do we know whether a compound is neutral? Whenever there will be a compound without having charges, we count that compound classified as the neutral compound. An example here, guys, we have got CaCO3. How to calculate the oxidation number? Usually in such compounds, all of the atoms we know, we have rules about them, only one remains, so we use this rule in order to calculate the oxidation number of the unknown atom. How? The oxidation number here of calcium is +2. Why? Because calcium is an atom, is an element in the second group, which we talked about, and the oxidation number of oxygen is -2. So why -2? Because it's the usual case of oxygen. The summation of the oxidation number here must be equal to 0. In counting the oxidation number, guys, this -2 is for one atom of oxygen. How about how many atoms of oxygen do we have? 3 atoms. So 3 multiply -2, it will be -6. Instead of carbon, let us write X plus X, and then the subscript of the calcium is 1. 1 multiplied 2 is +2 equals 0. Why equals 0? According to this rule stated that summation of the oxidation numbers of all atoms in a neutral compound must be equal to 0. So in this case, -6 plus 2 equals -4 plus X equals 0. X is equal to 4. So the oxidation number of carbon here equals +4. That's how we can calculate the oxidation number of the unknown atom in the neutral compound. Let us solve for the H3PO4, guys. H3PO4 in this case. The H3PO4, we know the tips, we have rule about hydrogen and oxygen, but we do not have any specific tip about the phosphorus. The oxidation number of hydrogen is +1. The oxygen is -2 because this hydrogen comes with the non-metal and the oxygen is the usual case. 3 and the phosphorus is X, we don't know. 3 multiply 1, +3, plus X minus 4 multiply -2, -8 equals 0. -8 plus 3 equals -5. X is equal to 5. So the oxidation number of the phosphorus here is 5. That's how we use the neutral compounds in order to find the oxidation numbers, guys. In order to find the oxidation numbers. Let me solve another example, guys. Suppose we have got Na2SO4 as the neutral compound. This is a neutral compound. Let us find its oxidation number. You know, sodium belongs to the first group elements, so its oxidation number is +1 and the oxygen is -2. 2 multiply 1 is 2. Instead of sulfur, write down X plus X. 4 multiply -2 -8 is equal to 0. So X is equal to -8 plus 2 -6. Takes to the other side, it will be +6. Therefore, the oxidation number of sulfur here in this case is +6. That's how we can use the summation of all atoms. Oxidation number equals 0 in neutral compound. The next rule, which is talks about the polyatomic ions, guys. You have studied that the polyatomic ions are a cluster of atoms which they have got a charge. Those you have studied the table of the polyatomic and monatomics. It said the summation of the oxidation number of all atoms in a polyatomic ion equals to the charge of the ion. Charge of the ion, not 0. Have a look. Let us solve for this example, guys. For example, here we have got H2PO4 negative. H2PO4 negative. This is a polyatomic ion. How do we know? Because a cluster of ion have got a charge. How to solve? Oxidation number of hydrogen is +1, guys, is +1. Oxidation number of phosphorus is unknown. We do not have tips about oxidation number of the oxygen is -2. Okay, 2 multiply 1 equals to plus X -8, 4 multiply -2 -8 equals the charge. So the charge is what? Is -1. That's how we equalize to the charge of the ion. X -8 plus 2 equals -6. Takes to the other side will be 6. 6 minus 1, it will be 5. So the oxidation number of phosphorus in this case is equal +5. Another example, guys, let us solve for the another example. Here we have got SO4 negative 2. SO4 negative 2. So the SO4 negative 2 is the sulfur is unknown, oxygen is 2 negatives. So X minus 8 equals minus 2. Why minus 2? Because the charge of that ion is minus 2 and X is equal to 6. Therefore, the oxidation number of sulfur here is equal to the 6. That's how we can use the rule of the oxidation number. Guys, if in some cases there will be 2 or 3 for the unknown, you have to multiply by the x, 2x, 3x, 4x. The other rule, which talks about whenever we have two nonmetals together in a binary compound, guys. The more electronegative element in a binary compound is assigned the number equal to the charge it would have if it were an ion. The oxidation number, guys, this is important, of oxygen in NO is negative 2. The oxidation number of Cl is more negative and has an oxidation number of negative 1. Guys, in some cases, suppose we have a binary compound CCl4. We don't know which one the oxidation number of these two atoms. But the more electronegative element, we have to decide from or begin to solve the oxidation number from the more electronegative element. How to know the more electronegative element? Guys, just notice that whenever we have a binary compound, always the less electronegative comes first and then followed by the more electronegative element. In these two examples, NO and CCl4, which one is the less electronegative element? The first element are the less electronegative elements, guys. And then the seconds are what? Are the more electronegative elements. This can be applied for all binary compounds, which they composed of two elements, two atoms. The first are the less electronegative, and then followed by the more electronegative. You have studied this in the previous stages, that how to write the binary compounds. First, the less electronegative, second, the more electronegative element comes. So in this case, if we return back the chlorine to the ionic form, to the monatomic, it takes the oxidation number of -1. So it's -1, and then use the rule of the neutral compound to calculate for the carbon. 4 multiplied -1, -4, plus X equals 0. So X is equal to 4. The oxidation number of carbon here is 4, and Cl is -1. The same for the oxygen. Oxygen, we know that it's usually -2, but suppose we do not know the oxidation number of oxygen, it becomes -2. Why? Because in the monatomic form, this is the more electronegative element in this compound. In the monatomic form is -2, and then -2 plus X equals 0. X is equal to +2. The oxidation number of nitrogen in this case is +2. More examples, guys. Suppose we have BF3. BF3 is a binary compound, and the more electronegative is fluorine. Fluorine in the monatomic form is -1. So 3 multiplied -1 minus 3 plus X equals 0. X is equal to +3. So the oxidation number of fluorine is -1, and the boron has an oxidation number of +3. The last rule, the last tip about the oxidation number, which is not given in the table of oxidation number in our curriculum, it talks about the halogens, guys. The halogen's oxidation number always equals negative. What halogen, we mean fluorine, chlorine, bromine, and iodine with the astatine, but we do not, in our book, there is no example talks about the astatine. So halogens, the F negative, Cl negative, Br negative, and I negative, guys. All of these, they have the oxidation number of -1, even within the within the compounds, except the case with the oxygen, because the oxidation number of the halogen changes with the oxygen. Have a look on the usual case and exceptional case as well. Let us provide some example, guys. In this case, AlCl3, we have got AlCl3. Let me just somehow zoom in. AlCl3, AlCl is -1, aluminum becomes +3. CaBr2, Br is -1, and Ca becomes +2. CSI, I is -1, and Cs is +1. In these cases, all of the oxidation numbers are -1 because it comes with the atoms except the oxygen. But have a look with the oxygen, guys. Have a look. ClO negative, oxidation number is 1. ClO2 negative, oxidation number is 3. How it changes? ClO3 negative, oxidation number is 5. ClO4 negative, oxidation number is 7. The same case with the oxygen, but with the different number of oxygens. The oxidation number of chlorine is 1, 3, 5, 7. The same for the other halogens. The oxidation number of halogens are -1 usually, but with the oxygen it's varied according to the compound, guys. Here we have got a question. The question said, it's somehow tricky question, said what's the oxidation number of iron in magnetite? This is magnetite, guys, Fe3O4, and carbon in acetic acid. As you can see, let us solve for the Fe3O4. Guys, Fe3O4, we have a tip about the oxygen in this case. The oxygen has an oxidation number usually as -2. 4 multiply -2 is equal to -8. And here we have got x, -8 plus 3x equals 0. 3 multiply x is equals 0. How about 3x equals 8? X is equal to 8/3. This is the mathematical the result of the oxidation number of iron in magnetite. But this is not true. This is true mathematically, but it's not logical, because the oxidation number must be a whole number, not a fraction always. Guys, what to do in this case? We cannot say oxidation number of iron is 8/3. 8/3 is a fraction, it's not a whole number. Instead, just know that here we have got 3Fe. 3Fe, guys. 2 of those atoms are Fe +3. One of those atoms are +2. So 2 multiply 3 equals 6 oxidation number. 1 multiply 2 equals 2. Summation equals 8. So 2 of the 3 atoms in the Fe3O4, they have got the oxidation number of +3. One of them has got the oxidation number of +2, and totally they will result in oxidation number of 8. The oxidation number for the carbon in acetic acid, guys. In acetic acid, this can be solved with the structure of the carbon. Carbon combined, the first carbon combined with 3 hydrogens, and then with the other carbon bonded with the oxygen, and then hydrogen, and then a double bond with the oxygen. Guys, have a look. the oxidation number of the surrounding atoms must be balanced with the central atom. We will take that technique in order to find the carbon's oxidation number. By the way, the two atoms, they have different oxidation number in this case. That's why somehow this example is tricky. The oxidation number of hydrogen is positive 1, positive 1, positive 1. So surrounding this atom, how many hydrogens do we have? 3. 3 hydrogens. Totally they will get a 3 positive oxidation number. 3 positive are surrounding. What should be the oxidation number of carbon in order to balance that positive 3? It should be negative 3. So the first carbon has an oxidation number of negative 3. How about the second carbon, guys? The second carbon, the surrounding atoms, oxygen is negative 2, this oxygen is negative 2, and that hydrogen is positive 1. So how we can determine the oxidation number of carbon? Summation of these must be balanced by the oxidation number of the central atom. -2 minus 2 minus 4 minus 4 plus 1 minus 3. So the surrounding equals minus 3. This should be positive 3 in order to balance the surrounding oxidation numbers. So in this case, the first carbon is negative 3, the second carbon is positive 3. We have got another case which is in the chapter review, guys. How to find the oxidation number of manganese, in this case MnCN by 6 negative 4, MnCN by 6 negative 3 plus 1 electron. Guys, how to solve this? We let the Mn as unknown, as X, and refer back to the cyanide. Cn is cyanide. Cyanide has an oxidation number of -1. So the oxidation number of this is -1. Both, I mean, it's a polyatomic ion. Okay. How to solve? X plus the number outside the bracket must be multiplied by the oxidation number inside. 6 multiplied -1, it will be -6. Equals what? Equals to the charge of the ion, because it's a charged compound. -4. So X -6 takes to the other side, it will be positive 6. Positive 6 minus 4, it will be 2. The oxidation number of the Mn in this case is what? Is positive 2. How about in the product side, guys? What will be the oxidation number? Oxidation number MnX minus this. In this case, the oxidation number of cyanide is -1, the same as here. 6 multiplied -1 is -6, equals -3. Why? Because the charge is -3. X is equal to -6. Becomes +6 plus 6 minus 3, it will be positive 3. So the oxidation number of the Mn in this case in the product side is positive 3. In the reactant side, positive 2. In the product side is positive 3. That's how we can calculate for the oxidation numbers. Another example let me provide about the Al2 SO4 by 3. How to calculate the oxidation number? Guys, for such compounds, we can calculate the oxidation number by using two tips. First, by dissociating this compound and using the monatomic and polyatomic rule, or by using the rule of the neutral compound. Let us do for the neutral compound. Aluminum, you know, guys, is positive 3. Sulfur, it's X. Oxygen is -2. Okay. 2 multiplied 3 is positive 6 plus 3. I provide this example in order to let you to know what to take into consideration. You have to consider the 3, the outside the bracket, and multiply to the inside the bracket's oxidation number. 3 multiply X is what? plus 3x. 3 multiply 4 is 12. 12 multiply minus 2 is minus 24 is equal to 0. Why 0? Because we count this as the neutral compound, as its neutral compound. 3x 24 minus 24 plus 6 is minus 18. Minus 18 takes to the other side, it will be 18. In this case, therefore, x is equal to 18 divided by 3. Okay, you get the 6. The oxidation number of sulfur in this case is 6. How to calculate by another procedure, another mechanism, guys, Al2SO4 by 3. Let us dissociate this two. You'll get what? 2Al positive 3 plus 3SO4, 2 negatives or negative 2. Okay? In counting the oxidation number, so it's obvious that the oxidation number of aluminum is here is positive 3. The oxidation number of the sulfur can be calculated by using the polyatomic rule. X 4 multiply minus 2 is minus 8 plus x equals minus 2 and x is equal to 6. That's how we can use both methods to calculate the oxidation number of the sulfur in this compound. This is the table 1 which represents the rules for assigning oxidation numbers, guys. What will be what's the effect of the oxidation number on compounds, on the color of the compounds? You can see in these different solutions, a different oxidation number, it has got different colors. What is this different status? In all of them we have got chromium, guys. Chromium, but with different oxidation states. That's why we have got different colors. Have a look. Here we have got chromium chloride, guys, CrCl2. It's blue, and oxidation number is positive 2. When it becomes chromium 3, that was chromium 2 chloride, here chromium 3 chloride is what is green. And the oxidation number of chromium is positive 3. How about K2CrO4? The chromium in this case changes to positive 6 and it has a color of the yellow color. And the K2Cr2O7 solution, the chromium has the orange color and its oxidation number is positive 6. So as you can notice, changing the oxidation numbers changes the color of the solutions in different compounds. That's how the oxidation number affects on the color of the compound, guys. Another effect of the oxidation number is that whenever the oxidation number sometimes can decide the formation of the compounds, guys. Let me provide an example about that. The oxidation number determines when the oxygen and sulfur they combine. If the oxidation number of sulfur is positive 4, or if it's positive 6, what will be the formed compound? Guys, when sulfur and oxygen, you know that the oxygen, it has got an oxidation number of negative 2. In the first case, you have to get SO2 in order to get the oxidation number of sulfur positive 4. Why? Because we can calculate that the oxidation number of oxygen is negative 2. 2 multiply negative 2 is negative 4 plus x equals 0. X is equal to 4. So in this case, the oxidation number of sulfur is 4. That's why we form a compound which is SO2, sulfur dioxide. But if it's positive 6, sulfur, you get SO3, not SO4. The SO3, 3 multiplied minus 3 minus 6 plus x equals 0, x is equal to 6. So in this case, the oxidation number of sulfur of 6. Just notice that how the oxidation number, as the oxidation number changes, that changes the identity and the structure, the property of the compound. This is the physical effect, and that's the chemical effect. Here physically, the color of the compound or the solution changes. Here the structure of the compound as well changes. There as well the structure of the compound changes. As the oxidation number changes, that changes the physical and chemical property of the elements, the atoms, and the compounds as well. Let us talk about the processes of oxidation and reduction, which are the main part of this section, guys. Oxidation refers to what? To the state or the process when an atom is losing electron, So most of the metals, there will be on the process that occur on most of the metals will be the oxidation. That's why let us define a process in which the atoms or ions of an element experience an increase in oxidation state from reactant to the product. There will be increase in oxidation state and losing the electron, guys. Have a look on this reaction, guys. Na goes to form Na positive one. Okay. What happens to the oxidation number from 0 till positive 1? So we have increased the oxidation number, or increasing in oxidation number of this sodium. That's why we call this process as an oxidation. Guys, in the reactions of the oxidation and reduction, we have to balance the electrons which lose or gain it. How to balance the charges or the electrons that lose it in oxidation? We have to write the number of the electrons, in the product side always, to balance the charges. So we have written what's the difference between the oxidation number? 1. So write down 1 electron in the product to balance minus 1 plus 1, you get 0. Okay, that's how we write down the electron in the product in oxidation half only in order to balance the charge. The oxidation state of sodium has changed from 0 to 1. That's why we have increasing in oxidation number. We can say this process is an oxidation process, and the electron to balance the charge must be written in the product side. A species whose oxidation number increases is oxidized. So in exams there will be such questions, guys. Which of the species in the process oxidized? The one that the oxidation number increases from reactant to product, or we can say that the atom which there will be the oxidation number in the oxidation state increases from reactant to product. Which can be oxidized? Of course, the atom in the reactant, guys. So in this case, Na or Na positive one oxidized, Na oxidized, guys. So the term of oxidized, and later we'll be talking reduce it, are used for what? For the reactant side only. And in this case, sodium atom, not sodium ion, is oxidized to a sodium ion. Here we have got the reaction of sodium and chlorine together. This figure represents the reaction of sodium and chlorine. React vigorously to form NaCl, guys. Sodium and chlorine, Na plus Cl2 to form NaCl. Of course, 2 NaCl and 2 Na. And in this case, Na changes to Na 0, because it's neutral atom, becomes positive 1, and Cl2, which is negative 0, it becomes negative 1. So what happens to the Na? Oxidation. Why? Because there is increasing in the oxidation number. About the chlorine, we'll be talking about the chlorine. There will be a reduction on the chlorine and oxidation on the sodium. Why? Because reduction, there is reducing in the oxidation number of the chlorine from reactant to product. Let us provide some more examples for the oxidation reactions, guys. Suppose aluminum changes 0 to aluminum positive 3. So why we wrote 3 electrons? In order, as I told you, we write always the electron to balance the charge in the product in oxidation half. How many electrons should we write? The electron which equals to the difference of the oxidation number from reactant to product. The difference between 0 to 3 is 3. That's why we wrote the 3 electron. Which atom oxidize it? Of course, aluminum oxidize it to form aluminum positive 3. Zinc from 0 to positive 2. So to balance the charge, we wrote the 2 electron in the product, and zinc is oxidized to zinc positive, Zn positive 2, zinc ion. Iron from positive 2 to positive 3, so 1 electron in the product. Here we have got oxidation, Fe positive 2 oxidized to Fe positive 3. Cl negative 1 to Cl2 minus 1 till 0, we have increasing in the oxidation number. We wrote 2 electron. Why? Because this difference minus 1 till 0, we have for 1 atom. How about for 2 atoms? Here we have got 2 atoms. There will be 2 electrons. For 1 atom is 1 minus 1. For 2 atoms will be 2. So the difference minus 1 to 0 is 1. But for 1 atom, here we have got 2 atoms. That's why we wrote 2 electrons. So in this case, Cl negative oxidized to Cl2. Properties of oxidation. We have got 3 terms that we can use for the oxidation. In oxidation, electrons are lost. The atom is going to lose the electron. Oxidation number in the oxidation increases, and then electrons written in the product side always. We have to know these properties of oxidation, guys. How about reduction? Let us talk about reduction. Guys, reduction must be present with the oxidation always. Why? Because the atom which lose the electron, there should be another atom to gain that electron. So we said the oxidation is losing electron, reduction is the gaining electron. All is a process in which oxidation state of an electron decreases are the reduction processes. Decreasing in the oxidation number from reactant to the product, we can classify that process as the reduction process. In this case, guys, have a look. Cl2 goes to form Cl negative 1. 0 to negative 1, there is reduction. 1 for 1 chlorine. How about 2 chlorines? 2 chlorines, there will be 2. So we write 2 electrons in the reactant. Instead of writing in product, which we wrote for the oxidation, here is the opposite. We write in the reactant. Why we write in the reactant? Because in the product we have got 2 negative. 2 multiply negative 1 is negative 2. Here we have got the 0. The charges are not balanced. Negative 2 and 0. How to balance these two? By addition of electron. What should be added for the other side to balance this negative 2? The negative 2 electron must be added to other side. So here we have got 2 negatives. 2 negatives. We have balanced the charges. The species that undergo a decrease in oxidation state is reduced. So in this case, which one reduced? Of course, this as the oxidized always must be in the reactant side. Reduced term, use it for the reactant side. in this case, chlorine atom, reduce it to form the chloride ion. The example for this example, guys, as I have written above the equation, it's the copper oxidized and nitrogen, copper oxidized and nitrogen dioxide is produced when this is a penny of copper, is placed in a concentrated nitric acid solution, guys. When we add copper into nitric acid solution, what will be formed? Copper nitrate and then NO2 as a gas, H2O as a liquid. What happens to the copper, guys? Let us test. Copper here is 0. There is positive 2. So 0 to positive 2. What happens in the oxidation state? Increasing oxidation state. That means oxidized or oxidation process. So copper oxidized as it's written here. How about the nitrogen, guys? The nitrogen atom, let me just, okay. The nitrogen atom here, oxygen is positive, hydrogen is positive 1, oxygen is negative 2, 3 negative multiply negative 2 is negative 6, plus 1 is negative 5, so the nitrogen here is positive 5. How about the product in the nitrogen? Here again is negative 5, that's why it's positive 5, sorry, that's why we do not count. How about in NO2? This is negative 2, 2 multiply negative 2, negative 4, takes to the other side by oxidation number. That's how the rules are important in determining the oxidation and reduction. It becomes positive 4. So from 5 to 4, what happens in the oxidation state? Reduction. That's why it's a reduced. Nitrogen in this case reduced and copper oxidized. Let us provide some examples for the reduction, guys. Suppose Zn positive 2, reduce it to Zn positive 2 to 0, reduction. How many electrons must be added to the reactant? 2 electrons, because the difference is 2. And Zn ion reduce it to the Zn. As I told you, always the reactant must be reduced or oxidized. The oxidized and reduced use it to the reactant side. Fe positive 3 goes to Fe positive 2, the 1 electron added to the reactant, and Fe positive 3 reduced. Al positive 3 to Al 3 to 0, 3 electron added to the reactant to balance the charge, and then Al positive 3 reduced to Al atom. Properties of reduction. If you remember, we talked about the properties of oxidation. We said oxidation, it's losing electron, but here it's what? Gaining electron. Oxidation, there will be increasing in oxidation state, or oxidation number, but here oxidation number decreases. In oxidation, we write the electron to balance the charge in the product, but here the electrons must be written in the reactant side. Oxidation and reduction as a process. Guys, the oxidation and reduction usually, frequently, they must come together, process at the same reaction within the same processes or the same systems. So we will be talking about each processes in half, and then the overall reaction. Oxidation half and reduction half in process. Electrons are released in oxidation and acquired in the reduction. This must be known that the electrons released in oxidation process, it's releasing of electron, but in the reduction process, it's the acquiring the electron. If oxidation occurs during a chemical reaction, reduction must also occur. So we do not have a process alone. The both must occur simultaneously. The number of electrons lost must equal the number of the electrons gained in order to meet the law of conservation of mass because the electron which loses in the oxidation must be equal to the electron which gained in the reduction to meet that law. Mass of elements, number of atoms, and the electrons that are exchanged are conserved equal. Also, with the electrons, with the charges, the masses must be equal. We have to balance the mass by what? By the coefficient. We balance the electron by addition of electron in oxidation to the product side, in reduction to the reactant side. Any chemical process which elements undergo change in oxidation number is an oxidation reduction reaction. So the reactions which the elements undergo through increasing or decreasing in oxidation number, oxidation states, we call as the oxidation reduction reaction, and abbreviated by the redox reaction. Redox reaction represent the reduction oxidation reaction, guys. We have got two halves in oxidation or in redox reaction, guys. The half, a part of each reaction involving oxidation or reduction alone, can be written as a half reaction. What's a half reaction? In the oxidation reduction reaction, we have got two processes. Each of these processes alone are the half reaction. Oxidation half and reduction half. When we combine these two, we'll get an overall reaction, overall redox reaction, which is the summation of two half reactions. When we add the oxidation half with the reduction half, we'll get the overall reaction, guys. Number of electrons involved is the same for oxidation and reduction. They cancel each other out and do not appear in the overall chemical reaction, guys. The number of electrons which we write for balancing the oxidation half in the product must be the same as the number of electrons which we write in the reactant for the reduction, and then when we add these two together, the electrons cancel out. We do not write down the electron in the overall reaction. How? Let us examine this example, guys. Here Cu, which is 0 atom, goes to Cu ion. As you can see, we have increasing process in the oxidation state. That's why this is the oxidation half reaction. How many electrons added to the product? 2 electrons, because the difference between 0 and 2 is 2 electrons. How about the other reaction? NO2 plus 2 electron. NO2 plus hydrogen goes to form NO2 plus 2H2. This is reduction half. How do we know it's reduction half? As you can see, the nitrogen goes to from the NO3 to NO2. From NO3 to NO2, we have got from 5 to 4. 5 to 4 is 1, but for the 2 nitrogens here, we have 2 electrons in the reactant. So the 2 electrons must be added to the reactant side. How to write the overall reaction, guys? We cancel the electrons in the product of the oxidation and reactant of the reduction, then they will be cancelled. We do not write the electrons which are lost or gained in the overall reaction or the overall equation, because they will be cancelled. If not, one of them is 1, the other, we'll be talking about this in balancing the redox reaction. We have to multiply if this is 2 and that's 1, multiply this by 2 in order to get all the reaction must be multiplied by 2 to get the 2, and then we'll be able to add the 2 halves. So whenever we have got 2 halves, the oxidation losed must be equal to the gained. If not, we have to equalize them, and then we'll be able to add those 2 to get the overall reaction. Here we have got some notes as a summary. Electron lost in oxidation appear on the product, as you know, of the oxidation half. We have practiced it. Electrons are gained in reduction and appear in the reactant of the a reduction half reaction. For a reaction to be classified as redox reaction, the states of two species must be changed. So one of them alone is not a redox. Both must be occur simultaneously at the same time to be classified as the redox reaction. The number of the electrons which added to balance the charge is the same as the differences of oxidation number of an atom in reactant to product. As I told you, how we add 2, 3, 4 is the difference between the oxidation number of the atom from reactant to the product. How to balance the charge? We have a technique or two techniques can be used to balance the charge. One by oxidation number, one by taking the total charge from reactant to product. The first, guys, add the electrons as the difference of oxidation number of an atom in the reactant to product. So the electrons, how many electrons must be added? Take the difference of the electron from reactant to product. In this case, Cu is 0. Cu, 0 oxidation number. Goes to what? Cu positive 2. So the difference between 0 till 2 is what? Is 2. This is oxidation. So the difference is 2. 2 electrons must be added to the product. So we added 2 electrons to the product. This is the first technique by taking the difference between oxidation number from reactant to product. Okay. The B, by taking the differences of the charges, guys, of the charges. Can be taken as the difference of the charges. How? The added electron equals to the difference of total charge of reactant to product. The same reaction, Cu goes to form Cu positive 2, guys. What's the charge of the reactant? Is 0. How about charge of the product? Is positive 2. So 0 to positive 2, there should be addition of 2 electrons to the product in order to neutralize this and become 0, becomes equal charges. That's how we can take the oxidation number, we can write the number of the oxygens to balance the charges in two ways. One, by taking the differences of oxidation number, the second differences in the charge of the reactant to the product, guys. Are all the reactions redox reaction? No, of course, we have some of the reactions which are not redox. The examples for the which are not redox usually are double displacement reactions between salts and reactions of acids with the bases are not redox, guys. The double displacement reaction between two solutions of salts and the reaction between the acids with the base neutralization reaction usually are not what? Are not redox. How we know a reaction is not a redox? If there will not be any change in oxidation number of atoms in the reactant to the product, that cannot be classified as redox. Have a look on the above example, guys. SO2 plus H2O formed H2SO3. The oxidation number of the S is positive 4, the S is positive 4, so there is no change. Oxidation number of oxygen is -2, here is -1, -2, hydrogen +1. So there is no change in oxidation number. We can say this is not a redox reaction. It's not a redox reaction. Another example, which is the double displacement reaction between NaCl and AgNO3. Na is positive 1, they're positive 1. Cl negative 1, they're negative 1. Ag positive 1, here positive 1. N positive 5, here positive 5. Oxygen negative 2, negative 2. So as I told you, the double displacement reactions between the salts and the reactions between acids and bases are not redox reaction. The oxidation states of all element species remain untreated in this composition reaction, so therefore this is not a redox reaction. In the above equations examples it's represented. And reaction between acids and bases, let me provide an example for that, guys. HCl plus KOH. We produce KCl plus H2O. Have a look on this example, guys. We said neutralization between acids and bases are not redox. The oxidation number of Cl is H is positive 1, Cl negative 1, positive 1, negative 2, positive 1. Positive 1, negative 1, positive 1, negative 2. There is no change in the oxidation number. That's why this is not a redox reaction. Guys, are the redox reactions only specified for the ionic compounds? No, it's not the case. The covalent compounds or the molecular compound is which there will be covalent bonds in between the oxidation. There will be change in the oxidation number, and then the oxidation state changes. That's why the redox reaction is not only specified for the ionic compounds. Substances with covalent bonds also undergo in the redox reaction, such as HCl, H2SO4, H3PO4. These compounds are molecular compounds. There will be covalent bonds in between the atoms. The oxidation number, when they react, there will be change in their oxidation number, and then we classify them as the oxidation reaction. The oxidation number assigned to a particular atom is based on its electronegativity of the atom. So the electronegativity relative to the other atoms to which it's bonded in a given molecule. It's not based on any charge of the atom. The electronegativity, guys, is not based on the charge. Here I have provided the difference between charge and the oxidation number. The oxidation number is related to the electronegativity of the atoms. What the electronegativity of the atoms represent? It represents the pull, the attraction of the tendency of atoms to pull the electrons toward themselves. A change in oxidation number does not require a change in actual charge, guys. If we are not restricted to say that always the charge must be changed to change the oxidation number. Have a look on the examples. The actual charge of chlorine is -1, but in different compounds with in this acid, it changes the oxidation state or the oxidation number. For example, in this case, oxidation number of chlorine is +1, becomes +3, becomes +5, +7. What happens to the oxidation number changes, but how about the actual charge? It stays unchanged, -1. Another example, H2Cl2 to form HCl. H2 is 0, becomes 1. Here we have got oxidation. So the hydrogen atom oxidizing. Cl is 0, becomes -1. It's reduced, and chlorine atoms are reduced in this case. 2 electrons lose it and 2 gain it in this process. Hydrogen has donated a share of its bonding electron to the chlorine, but has not completely transferred that electron. That's the difference between charge and the oxidation number. Neither atom has totally lost or gained the electron in the above, because we have got what? Sharing electrons in between. That's an example to show that the oxidation number is not specified only for the ionic compounds. There will be a redox reaction, changing in redox reaction for the molecular compounds as well. The assignment of oxidation number allows an approximate of the electron distribution of a molecule. So the oxidation number talks about what? Distribution of the electron on the molecules. Here I have represents a difference between the oxidation number and charges of ion, between the charge and oxidation number. Let us talk about the differences in detail. We have got 4 differences, main 4 differences. First, the oxidation number indicate what? Indicate electron sharing on transferring in a bond. But the charge indicates actual electrical charge of an atom or ion. Here indicates what? The sharing or transferring of electron. Can be shared or transferred. But here indicates the charge between the ions, the atoms which they form, ions. Applies to atoms in a molecules or compounds. The oxidation number can be used for the compounds and the molecules, but here applies to ions or charged species only. Charged species only, the ion. Can be positive, negative, or zero, but here can be only positive and negative, it cannot be zero. Has no physical meaning. The oxidation number has no physical meaning in terms of saying it's just a magnitude of something, but the charge has a physical meaning which represents the number of electrons transferred between atoms. It represents the number of the electron transferred between the atoms. It's a physical meaning, but the oxidation number, it has no physical meaning to be stated about. Guys, the reactants and products in a redox reaction are not limited to monatomic ions and uncombined element only. Sometimes the polyatomic ion must be reduced, the cluster of atoms must be reduced altogether. So whenever the oxidation state of an atom in a compound, in a polyatomic ion, changes, we will not say the oxidation number of the atom changed. We have to say the oxidation number of the whole polyatomic ion changed. Elements in a molecular compounds or polyatomic ions can also be oxidized and reduced if they have more than one non-zero oxidation state. Have a look on this example, guys. NO3 negative goes to form NO2. In this case, nitrogen reduced. But we cannot say only nitrogen reduced, because the nitrogen is clustered with the oxygen to form NO3 negative. We can say the nitrate ion reduced to nitrogen dioxide. The nitrogen reduced, but the whole polyatomic can be taken as the species that reduce it. We cannot take nitrogen alone. Instead of saying that the nitrogen atom is reduced, we say the nitrate ion is reduced to nitrogen dioxide, guys. Here we have got the section review questions, guys. Let us solve a few questions, then we will end the session. Label each of the following half reaction as either oxidation or reduction. Guys, it's simple. Whenever the electron written is in the product side, that's oxidation. In the reactant side, it's reduction. So it's in the reduction side, reduction. Reaction side, reduction. Oxidation. Second, this is in the reactant side, reduction. Product side, oxidation. Reactant side, reduction. That's how we can determine whether it's half, oxidation half or reduction half. Find redox equation, determine which element is oxidized and which is reduced, guys. Which element oxidized, which is reduced. Here we have got positive 1, 5 minus 2, positive 1, negative 2, 0, minus 4 plus 3. So in this case, nitrogen reduced from 5 to 3, oxygen from minus 2 till 0. So the nitrogen reduced from 5 to 3, oxygen oxidized from minus 2 to 0. Hydrogen is 0, copper is positive 2, oxygen minus 2, copper is 0, hydrogen positive 1, minus 2. Hydrogen atom oxidized from 0 to positive 1. The copper ion reduced from positive 2 to 0. Na positive 1, Na positive 1, oxygen minus 2, hydrogen positive 1. in this case, there will be hydrogen positive 1, Cl negative 1, and then Na positive 1, Cl negative 1, positive 1, negative 2. What happens, guys, to the oxidation states? Na unchanged, oxygen unchanged, hydrogen unchanged, Cl unchanged. So it's not a redox reaction. It's not a redox reaction. Why? Because it's a reaction between acids and bases, as I told you. We have checked it and tested. It's not a redox. There is no change in the oxidation states. Let us solve for the D. Hydrogen 0, chlorine 0, positive 1, negative 1. Hydrogen oxidized, chlorine reduced. S is positive 6, negative 2, positive 1, negative 2, positive 1, 6, negative 2. There is no change in the oxidation number, so it's not a redox reaction. C and E are not the redox reaction, guys. Here we have got the section review, the test bank for the section. The sum of the ministerial exam questions, let me solve some of the ministerial exam questions. Said which oxidation number is the biggest for xenon element in the below. Xenon is 0 here, guys, and cesium is positive 1, negative 1. 8 multiply negative 1, negative 8, plus X for xenon, plus 1 for the cesium, equals 0. X is equal to 7. So the first one, the first is 0. The second is 7. Okay. Let us solve for the xenon OF2. Guys, this is not the case to say oxygen comes with the fluorine. Don't be confused in this. Oxygen is not alone with the fluorine. So it's the usual case of the oxygen. It's the usual case of the oxygen. X minus 1 plus minus 2. Sorry. Minus 2 for oxygen. So X minus 2 minus 2, 2 multiply minus 1 minus 2 equals 0. X equals 4. In this case, the third one equals 3. 4. Equals 4. How about NaXeO3? NaXeO3. Na is positive 1, group 1 element, X minus 2. Minus 2 multiply multiply 3 minus 6 plus X plus 1 0. X is equal to what? Is equal to 5. So the fourth one is 5. Which one is the biggest? Of course, the second is 7. B is the correct answer. Which reaction is not redox? Which reaction is not redox? Probably in exam, double displacement reaction and acids with bases are not redox. But let us test here. The carbon is 0, goes to 4. Oxygen 0 minus 2. This is redox. Ammonia with the HCl. Ammonia plus 3. Okay, minus 1 plus 1 minus 1. 4 multiply 1 equals 1. 3 plus 1 negative 1. So this reaction between the acid with the base, it's the correct answer, which is another redox. Which is the oxidation number of S in HSO4 negative? Positive 1, negative 2. 4 multiply negative 2, negative 8 plus 1 plus X equals minus 1 because it's minus 1 the charge. X equals minus 8 plus 1 is minus 7, takes to the other side plus 7, minus 1 becomes 6. So 6 is the correct answer. D is the correct answer. Which of the following is oxidation reduction reaction? Oxidation reduction reaction, there should be both halves together. So the first one is only the oxidation. One half cannot be the oxidation reduction reaction. The last one, D, is also reduction only. Let us check which of them there will be reduction and oxidation both. Sulfur is, in this case, is positive 4. In that case is positive 6. Oxygen is 0. Here is minus 2. And oxygen minus 2. Okay. What happens to sulfur? Oxidation. What happens to the oxygen from this O2? Reduction. So this is a redox reaction. How about the N2O4 goes to NO2? In this case, the nitrogen, it's 2x minus 8 equals 0. 2x equals 8. X is equal to 4. So the nitrogen's oxidation number is 4. There is 4 as well. There is no change in the oxidation number of nitrogen and also oxygen. It's not a redox. B is the correct answer, which is a redox reaction. The oxidation number of the atoms in H2O2 The first, this is the peroxide case, guys. The hydrogen is positive 1 and the oxygen is negative 1. Positive 1, negative 1. Positive 1, negative 1. So hydrogen is positive 1, oxygen is negative 1. What's the oxidation number of monatomic ion? Equals to the charge of the ion, its charge. C is the correct answer. Which of the following reaction is not a redox reaction? Reaction of which are not redox, we have to take into consideration. This is 0, 0, plus 2 minus 2, it's redox. H2O plus 1 minus 2 plus 4 minus 2 plus 1 plus 6 minus 2. So in this case, we have got sulfur oxidized, but there is no reduction. Also, it's not a redox reaction. This is a redox reaction. It's not a redox reaction. A is not a redox reaction. So A is the correct answer because it's required. Is not a redox reaction. About the critical thinking, guys, said the following reactions are given. Na atom goes to form Na ion plus 3 electron. Al positive 3 plus 3 electron goes to Al. Said explain how this reaction is said that the charges is conserved in the reaction. The charges are conserved because the number of the electron lost equals to the number of the electron are gained. This is representation. Explain how this reaction is said that the mass is conserved. The mass, the number of the atoms of Na in the reactant 3, product 3, aluminum in the reactant 1, product 1. So the number of the atoms in the reactant and product are the same. Explain why electrons do not appear as reactants or products in the combined equation, overall equation. Because as we discussed about, when we add the two halves, the electron which lost cancel out with the gained electron, there will not be, we will not write the electron in the overall reaction. Thank you for the